Hello everyone, in this video I will show you how to make a smart power distribution box in details, because we have made many different solutions of the power distribution box. You can see here that is our YouTube channel. You can see this is for 4 years ago, and 3 years ago, and 2 years ago, and this year. So this video have many views. You can see this is the millions, and this almost 270 views. And also we can see here there are many user comments. So there are some questions, and so this time I make this video and explain this in details and tell you how this power distribution box works, about the hardware and about the software. And here we can see this video we have used this KC868 server. And also this mainly in 2023 we have made these 2 videos. And these 2 videos just used by the 2 different solutions. But for the home automation, the first thing you need to confirm is which software you will use. And the 2 solutions mainly is according to the network. By internet, remote controlling your mobile phone, by the cloud server, or without cloud server, just using local network. So there are 2 options for you, the software. The first one is using local network. It can work without internet, just work in your house, in your home local network. And the second is used by the cloud server. You can use your mobile phone or you can use your computer in anywhere. So these 2 solutions you need to confirm firstly when you begin to make your home automation project. And so this we have made the 2 different solutions, and this solution is used in local network. So today we will use this solution for explaining it, how it works. And this solution you can see here, that is used by the Tuya mobile phone application directly. That is used by the Tuya IOT platform, the cloud server. So Tuya is the most popular use in these years for home automation project. So the first thing, the important you need to confirm your project, which solution you need to use. And the second, I will show you how to choose the hardware and the hardware, how it works. So this is a different solution, and this video and is this local network solution. So let's look at this can use by the home assistant software. And you will see this is the KC868 server. And these details you can see these videos. And this because used by the Raspberry Pi. So you can install the home assistant on this Pi. And this you can see this power meter and a local server, and used by the mobile phone, or can used by the tablet, or used by the computer. So this function is also very powerful, used in local network. And the temperature you can see monitoring the history, the temperature history, and the IR extend for controlling your air conditioning in long distance. And this is used by the RF remote, a wall switch panel. And this is energy meter. You can detect the voltage and the ampere and the power. So this all can use by this local server. And also you can use Node-RED to create your own functions. And you can see this is Alexa. So this is the Node-RED. So this video you can see here also is step-by-step all progress, how to make it. Okay, this is how to DIY this step. And this time in this video, so I will show you just this box and how it works by this hardware, and I will show you a schematic and how it works, connect with all parts together. And the first I have said the important is choose the software. You can see this is our home assistant software. This is used in local network, but this software you need to configure. So you need to have some home automation skill, because you can see here that need to configure these files. You can see this code you need to configure. But if you use Tuya application without any config, without any program, just directly to use, so it's very easy. But this needs to configure. But the Home Assistant software, you can see that is open source and free to use, and often update and free to use. And this is Home Assistant demo. You can see this online demo. You can see the light and the energy meter and the air conditioning and many different functions you can create and just according to your config file. So I have used this. You can see this overview, and you can see I can turn on this contact, just this channel 1. And this energy meter, you can see energy meter, and this temperature sensor. You can see I have added this temperature sensor to detect the power distribution box inside the temperature. If the temperature is high, so I can turn off relay to protect the circuit. And you can see I can turn on all relay and turn off all relay. And this is digital input for the sensor state. And the 8 channel, you can see the blue terminal. If I shut for this is ground. If I shut for this the 8th channel, and you will see this is on. You can see the input is on. And if I click this one, you can see the history will show for you, and what time is on and what time is off. You can see this is off because I release my trigger. So this is can make your own dashboard for on and for off and country, and some dimmer you can add to this dashboard. And also you can use your mobile phone. If you use Home Assistant, you can install the Home Assistant application. You can see here. So you can see you can use your mobile phone. You can see turn on the switch and turn off. It's here. So this is also very powerful, and you can see that energy meter and some details, some history date. Also you can see it here. So that can use the mobile phone and your PC at the same time. So this is the Home Assistant about the software. And also you can use the ESP Home. You can see the ESP Home because the server have an ESP Home interface, some hardware resource you can configure by yourself. Okay, now let's look at the next. We can see the schematic, how it works about the hardware and the controller. And you can download this schematic and from our phone. So you can see here, that is a schematic, how it works and in details. And now I will show you how it works. This is our schematic. And in this diagram, you can see this have some brick and energy meter and power supply. And this is KC868 server. And this is the contact, DC contact that used by the DC 12 volt or 24 volt. And this is external relay module, and this is a terminal for your loads. So this is the most important, is KC868 server. And you can see there are some details about the KC868 server. And because it's a computer, we can see the PCB board. And you can see, actually this is a Raspberry Pi 4 computer. And the system have this Raspberry Pi at the right side. And this left side is KinCony IO board. So this can work together. And also you can see here, that is E8. So just this board, this external relay board. Because this relay board have 16 ampere, you can see 16 ampere. So almost for your loads enough to use. Support install on the DIN rail. So this is second. And you can see here that is KC868 server. And also we have released the Miniverse, so that will be small and it will be cheap. And here you can see many lessons and many resources how to step by step tell you install the Home Assistant and make the power distribution box and configure the different function for Home Assistant. And all at here, I can't use some sentence in this one video. So you can see here is every topic have the video tell you how to step by step, and all have config file and how to step. Okay, this is the hardware diagram. We can see the diagram. And the first, you can see this is the main brick. The main brick, this is a single phase. But if you want to use a three phase, just replace this main brick. Just will input L1, L2, L3, and the neutral. So this time just for demo, so I have used a single phase, so that have the power single phase and leave line in and neutral line in. And here that will output the L is input to this energy meter. And when we look at this is our diagram on computer. Later I will show you the power distribution box, how it works in physically. And you can see here that is output at this energy meter, and this energy meter output at this 16 channel brick. This 16 channel brick, and this is fuse. This is not brick, this is fuse. And every output, brick output, you can see that will go to this contact or this external relay module. So output and goes through to this contact. Because the contact you can use for 25 ampere, and this external relay that have 16 ampere. So this is small current and this is big current. And if you want use larger than 25 ampere, you just replace this contact with large one. So this according to your load, the load's current, you can replace this contact. And this contact in and this contact out. And after out, you will see this connect with this terminal. And your lamp and your curtain and your different electronic device will connect to this point. This red is leave and this N is neutral. So every channel output have contact with this terminal. And also you can see this is the E8 board, relay extended board. Also is the red one go to the COM. You can see that is COM. And this is normal open. The normal open will output to this terminal. So this 8 channel you can connect with this max 25 ampere load, and this 8 channel you can connect with your max 16 ampere load. And this contact is DC. You can use for 24 volt or 12 volt. This contact coin work voltage. So if this A1 and A2 have 12 volt or 24 volt, so this contact will be closed. And if without the voltage, this contact will be open. And also this is a relay. This relay you can see here. This is KC868 server, 16 channel digital output. This 8 channel digital output is connected with this 8 channel DC contact. This another 8 channel is output to this release coin input. So this coin input will have 12 volt and this relay will be work. If without the voltage, and this relay will not work. And this white button is menu control button. Later I will show you how it works. And this is button. And also you can see this is menu control button at here. This menu control button is physically without call server, without internet, without your local network, just physically by this local work. Later I will show you how it works and tell you how to turn on and turn off manually. So this board is worked by the 12 volt. The orange terminal is 12 volt and the black is ground. And this controller, also you can use this 12 volt power supply for this controller, and also you can use the 24 volt all support, no problem. Okay, you can see here the schematic is simply, And this you can see, this is a power supply. This power supply is for DC 12 volt, 4 ampere, because that is for the power is for controller and for the contact and for the external relay board. And you can see this is leave line and go to this fuse. This fuse will protect this power supply. And this output and to this leave line, and this is neutral line. And this output DC 12 volt, if you use the 24 volt, you just replace this power supply with 24 volt power supply. So you can see that will output the power supply DC and connect to this controller and connect to this external relay module and this contact. So this is structure of the power distribution box. And at last you can see that energy meter. The energy meter use RS485 interface. You can see this A and connect with this A, and this B connect with this B. So that for RS485 Modbus protocol. So we can use the Home Assistant and integrate this energy meter to Home Assistant and show you some power and voltage and the current in diagram and in the UI interface. So this is the structure of the power distribution box. Okay, this is the diagram of the power distribution box, and next we will look at this box actually. You can see it here. And you can see this power distribution box, and this you can see this main brick and this energy meter. The energy meter will show the power consumer because my meter is new, so that is 000. And there also have some details, information. This voltage, this will be updated some seconds, the voltage. And this is the power, because no load I have connect. And this is the communication LED. That because I have connected with RS485 to this board, that will every some seconds to read this energy meter and this frequency. So this is for the energy meter. You can see this is power in, the AC power in, and this main brick, and this is power, and go to this energy meter, and the energy meter will go output at here for the 16 channel, this 16 channel brick, and this brick output, you can see the red output will go through this way and to this contact, and this is for input, this power, and this is output. So you can see the red is output. So every channel, 16 channel, have connect with the contact, and external relay. You can see this external relay. That is for the COM, this COM, this COM, and COM, and this normal open. That normal open have output, and the contact is output. So we'll go to this terminal. This terminal, you can connect with your load, maybe your lamp and maybe your curtain or your motor. Just connect it here. And I have connected with this. This is temperature sensor, so that can detect the whole box, the temperature. And also you can see here, that is the Ethernet cable I have connected with my loader. And this another Ethernet cable, because this have two systems in this box. And this half of this box is Raspberry Pi, and another side is KinCony controller system. So this have independently work network, and the system also is independently work. So you can see this network cable for Raspberry Pi, and the USB for Raspberry Pi, and the Type-C is download the firmware for the Raspberry Pi. And this HDMI, you can connect with a computer monitor, and you can use your mouse, your keyboard, and your computer monitor. So this is a computer. You can install any software on the box, just the Linux software. And this you can see that is output, the digital output, and this is the analog input I have not used. And this also have IS485. That is the sleeve IS485 mode. And this is IS232. And this IS232 you can integrate to your other system. And this is the Raspberry Pi IS485 interface. So I use Home Assistant, so this cable can connect with this energy meter directly for Modbus protocol. And here you can see that is the flows that have the AC input, and this output have connect with this one, because this one, that is L, and this is N. So that will output a 12 volt and 4.5 current, and this is 12 volt output. So this 12 output will go to here. For this controller, this 12 output. And also you can see that is 12 volt, this is 12 volt, and this is ground. And this one, you can see the positive one. This one is for 12 volt. Just from this output. If this output is 12 volt and go to here, that will work. And this is negative. The negative is connected with the ground. So you can see this 2 point is for the coin, the contact coin. And also you can see this one, this is for 8 channel, for this another digital output. This is for relay coin. This is relay coin. Is 12 volt will be work. And so you can see I have used the Home Assistant to control this device. And if you have disconnected the network cable, if the controller is broken, if it is broken, Raspberry Pi is broken, so this cable have disconnect. But we want the system, the load also can control manually. So you can see here, I can use this physically to control this contact on and off. So just very easy. And this not needed to use the software, just physically. So this is in the middle, that is controlled by the software and by the application. And at the down, that is turn off. This is off. And this is on. This is on. So this is on, and this is off, and this is auto. That means controlled by the software. So usually we will put at this auto position. So if you have some energy in emergency, so you need to turn on and turn off by manually. Okay, you can see this external relay board also have this function. You can see I can click. This channel will be on, this will be off, on and off. So you can see when I press this button, this relay coil, you can see here. So this also can work in locally. Without controller, you can see my controller is no network, so it also can work. And if you want use this switch panel, this momentary switch panel, you can connect with this to this terminal. That is for digital input. So you can set in Home Assistant. This can work with your lamp or with your curtain. So this also is working locally without network cable. Also can work. This is the type of the momentary switch. Just you can see that's key 1, key 4. 4 button. Just use this COM, and 4 cable, 5 cable. This is for LED indicate, because this panel has this LED indicate. So that can feedback from this controller. The relay is on and off. That will be on and off. And also you can use this switch panel. This is launch type of switch panel. If you use Home Assistant, you can connect with this cable and to this point directly. So you can set in Home Assistant, and when press this button to turn on relay or toggle relay, just according to your program. Okay. And we can see, let's power off. Power off. And you can see this is flush. Just you can open it, and you will see that is protect for this power supply. And this is 10 ampere. And some people asked, why this flush not replaced by this brick? Because this flush is fast when have short the circuit. That will faster than this brick, so that will faster disconnect to protect this controller system. The power and the controller system is important, so we need to use this flush to protect it. And this brick just protect for this output the load, so that you can replace by yourself, because this now we have used this 16 channel ampere because this is 25 ampere, that is 25 ampere, and this is 16 ampere, so we can choose this brick is enough to use. And let's look at some details. This is 16.3 ampere. This is for mid brick, just a mid brick. And when this power on, the power energy meter will show some information, brand rate, address, and frequency, and power consumer, and current. And this is brick. This is 20 ampere. 1, 2, 3, 4, 5, 6, 7, 8. The 8th channel is 20 ampere because the contact is 25 ampere. And this is 16 channel ampere. 1, 2, 3, 4, 5, 6, 7, 8. 8 channel is 16 ampere. So you can replace by yourself. Just this is a different ampere of brick. And this is a terminal. This terminal. And this is output. If you want output 24 volt, you just connect with here, power supply with 24 volt, and this two line, this 12 volt, also replaced with 24 volt power supply. And the temperature sensor, and this is GPIO, free GPIOs for ESP32, so you can connect with the DH18B20 temperature sensor, or you can connect with the DHT11, DHT22. That is temperature and humidity sensor together. Also, you can connect with your LED strip, WS2812. The colorful LED strip you can connect with here, and this extend the IR signal to control air condition or long distance device. And this download from the USB for ESP32. So if you want to download the firmware for ESP32, you just use a USB-C cable. You just connect it here. It's also very easy because it's Raspberry Pi. And this other side, you just connect it here. Okay, just use this one cable so that you can use the Raspberry Pi Home Assistant, download the ESP Home firmware for this ESP32 module. So that will be easy. Just connect with these two cables. Okay, and this contact. And this contact, you can see here that is the coin voltage. And this have two channel output. This is in, this is in, and another channel I have not used. If you want to use, you can use this is leave line in, and this is neutral line in. And at the bottom, you can see that is leave line output. And another at the bottom, you can see that have a hole that can output neutral line. So every contact that have 2 point output for neutral line and the leave line. I just use this one channel of this contact. Okay, I have explained this solution of the Raspberry Pi controller and work without CAD server. make this power distribution box. If you have any questions, you can leave your comments on our channel. Okay, thanks for watching.